Student, today we will start this law of conservation of momentum. Actually, law of conservation of momentum is very important topic of class 9, and we should study in detail because law of conservation of momentum is important for many of the phenomena. Many natural phenomena occurs that should follow law of conservation of momentum. What is this law of conservation of momentum and how we can prove this law? Because straight in the examination also question comes, statement we have to provide and we have to prove this law of conservation of momentum statement. So today we will study this thing in detail. First I will provide you the law and then I will prove this. So let us do that. In this chapter in class 9, second chapter that we are studying, there are some important topics like Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and then this topic, law of conservation of moment. This fourth topic basically very important. Numerical also coming from this topic, law of conservation of momentum. Actually, first I will give you the statement of law of conservation of momentum.
हम वीडियो करेंगे
Law of conservation of momentum statement. What is the statement actually? Statement very important. Total momentum.
बड़ा बड़ा देखिए
Total momentum of any isolated system remains conserved in the absence of any external force. Actually, this is the statement of law of conservation of angular momentum. So that I will write on the board. Again, I am repeating. In the absence of any external force,
नहीं
total momentum of any system, of any isolated system, remains conserved conserved means constant. Conserved means constant, same. And isolated means it is separate from any other influence, from other external force. That is isolated system. And momentum, we have got the idea mass into velocity. So for proving part, we should take example. What does it mean? Take one example where two spherical balls, one having mass m1, another having mass m2. First one is moving initially with velocity u1 and second one is moving with u2. They are moving along the same line. They are moving along the same line. So what will happen? If u1 is greater than u2, if black one has more velocity in comparison to further one, then what will happen? This will collide. So collision will take place. So maybe first body will collide with second body. During collision, there will be exchange of forces. Maybe F1 force will be applied by first body on the second, and second body in return will apply maybe F2 force. If collision time is T, the collision time is T. So what will happen? Collision time is T. And during this T, there is exchange of forces. And after collision, maybe both body is moving with different velocity. Maybe the first body is moving with velocity v1, and second body starts moving with v2. So before collision, total momentum we have to calculate. After collision, total momentum we will calculate. And we have to prove that total momentum before collision is equal to total momentum after collision. Collision is an event. In this event, only internal forces are taking place, exerting F1, F2 forces, internal force. But outside the system, no force is there. So what we see? Total momentum before collision. Total momentum of the system before collision. What is total momentum? The first body momentum, mass into velocity. Second body momentum, mass into velocity. So if you are adding these two, we are getting total momentum before collision. So that is before collision. After collision, we will see what will happen. Total momentum after collision is actually m1 v1 plus m2 v2. So we can write for pi I initial p for momentum, and maybe pf f final p for momentum. So what we have to prove? We have to prove that pi is equal to pf, or m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This we have to prove. For proving part, what we will do, we will use two laws, Newton's second law and Newton's third law. So we will apply these two laws of motion to prove this law of conservation of moment. So here what we see, F1 and F2 is acting equal and opposite to each other. That is according to Newton's third law of motion. And then what will F1 do, what the F2 will do, that we will see in proving case. So let us prove this. I am rubbing upper part, or we can do here also. This part also we can do. In proving part first, according to Newton's third law of motion. F1 is equal to minus F2. That means what? F1 and F2 are equal and opposite. To each action there is equal and opposite reaction. So that is we have to apply. And then in this we have to put the value of F1 and F2. Now using Newton's second law of motion, what F1 is doing actually? F1 is bringing, F1 is applied by first body on the second body. So in the second body there will be changing momentum. So F1 is bringing changing momentum in the second body. So what is changing momentum? Final momentum m2v2 minus initial momentum m2u2, that is of second body, divided by the time t, that is collision time. In this time only the momentum change has been taken place. So that is F1. So now what will be F2? Now if you are talking about F2, so F2 will be actually acted by second body and the first body. So there will be changing momentum of the first body. Final momentum of the first minus initial momentum of the first divided by a time in which momentum change takes place. So force is rate of change of momentum. We are using Newton's second law of motion. So if we are using this second and third in first equation, we are using second and third in equation 1. So what we see, if we are using second and third in equation 1, and here I am writing using equation 2 and 3 in 1, we get what we get here. In place of F1 we are writing this, in place F2 we are writing this. Now minus sign we have to break the bracket, and then minus into minus plus, all we have to see minus m1 v1 plus m1 u1, here m2 v2 minus m2 u2 minus m1 v1, we bring this side. So finally we are getting now see what we are getting actually. We have got the same statement what we needed to prove, that is total initial momentum of the system. System means here there are two body system, first ball, second ball. So here system means the first body and second body. So total initial momentum is coming total final momentum. So we have proved this statement. So actually this is very important topic. Again I am reminding you all, class 9 students, this will come in any examination, either half yearly or final, any competition. There are many applications of law of conservation of momentum that we will study in detail, and also numerical problem we can solve on the basis of this formula that we have derived. These are very important law in physics. Any of the phenomena in the nature without following this law could not occur. If any phenomenon has to occur, then that phenomenon should obey law of conservation of momentum. So for today, that is there, and again we will join next day, and we will study application of law of conservation of